Hello, in this video we're going to be talking about progressions. By the end of the next series of videos, we should be able to recognize the difference between a sequence and a series. We should be able to recognize the difference between an arithmetic progression and a geometric progression. We should be able to find the end term of an arithmetic progression and a geometric progression. We should be able to find the sum of both kinds of progressions. We should be able to find the sum to infinity of a geometric progression, and we should be able to determine when a geometric progression converges. Now to start, let's understand what we mean by a sequence. So here we have two sets of numbers. You recognize that these numbers are odd numbers from 1 to 11. But there's a major difference between these two sets of numbers. Now for this first set of numbers that we have here, you would notice that these numbers are in no particular order. We have 1, 5, 7, 11, 3, and 9. And for these, this is just a collection of odd numbers. And for collection of numbers, we call that simply a set. However, for the second set of numbers that we have beneath here, for this set of numbers, you would notice that they are in a particular order. They are in an increasing order from 1 to 11. And that is what we call a sequence. It is very important that for a collection of numbers to be considered a sequence, there has to be some form of order to it. It does not matter if the order is increasing or decreasing, but there has to be some form of order for it to be considered a sequence. Now that we've established that, let's look at some other kinds of sequences that we may have. So other examples of sequences that we may have include number 3 here, where we have a sequence of squares. As you can see here, 1 is the square of 1, 4 is the square of 2, 9 is the square of 3, and so on. So here we have a sequence of squares. And for the next example, we have a sequence of cubes. Now you would notice that this sequence here is in an increasing order, but here we have the sequences of cubes in a decreasing order. 216 is the cube of 6, 125 is the cube of 5, 64 is the cube of 4, and so on. So this is the sequence, this is a sequence of cubes, although in a decreasing order. Like we said before, a sequence just has to have an order to it. It doesn't matter if it's increasing or decreasing. And here, finally, we have a common sequence in mathematics, which we call the Fibonacci sequence. The Fibonacci sequence is simply derived by adding the preceding two numbers. So 1 plus 0 is equal to 1, 1 plus 1 equals 2, 2 plus 1 equals 3, and so on. Now, for each of the sequences that we have here, they all have 6 terms within them. But it's possible that we have a sequence with an infinite number of terms. For example, in reality, the sequence of squares is an infinite number of terms. Now, mathematically, we can indicate that a sequence is infinite simply by adding 3 dots to the end of the sequence. So when you see 3 dots at the end of a sequence, what it means is that this sequence contains an infinite number of terms. But it's also possible that we have a sequence where we have a large number of terms and we cannot write out everything. So we can also write the 3 dots, which normally would indicate infinity. But then we can, for example, I can write 377 here. Now 377 is the 14th term of the Fibonacci sequence. Now what this simply means is that between 13 and 377, there are other terms that I cannot write down here, but 377 is where we want this sequence to stop. So this is a finite sequence, while this is an infinite sequence. Algebraically, we represent the first term of a sequence with u with a subscript of 1, u2 for the second sequence, u3, up until un, where un is the final term of the sequence. So now that we have this little introduction, let's do a first example. So the example says, write the first 5 terms of a sequence given by un equals 3n plus 5, where n is an integer. So for this example, for n equals 1, our u1 is equal to 3 multiplied by 1 plus 5. 3 times 1 is equals 3 plus 5, that's equal to 8. And when n equals 2, u2 is equal to 3 multiplied by 2 plus 5. So that's 3 times 2 is 6 plus 5, that's 11. And when n equals 3, we have that u3 is equal to 3 multiplied by 3 plus 5, and this is equal to 14. When n is equal to 4, we have that u4 is equal to 3 multiplied by 4 plus 5. This is equal to 17. And finally, we have that when n is equal to 5, u5 is equal to 3 multiplied by 5 plus 5. So 3 times 5 is 15 plus 5, that's 20. So the sequence is 8, 11, 14, 17, and 20. Now that we have a little understanding of what a sequence is, let's introduce ourselves to what a series is. Now, a sequence is a series of numbers that are written in a particular order. A series, on the other hand, is obtained by adding the terms of the sequence. So if we were told here to find the series, if we had something to the end here where we were told find the series for this sequence. Now the series Sn is equal to 8 plus 11 plus 14 plus 17 plus 20. So we find our series by adding the terms of our sequence. And here we have that our series is equal to 70. Don't forget that the difference between a sequence and a series is that a sequence is a collection of numbers like we have here that is written in a particular order, while a series like we have here is gotten by adding up the terms of that sequence. So let's do one example involving series. The example says for the sequence below, find the series S1 to Sn. Now, while we know that the series is the addition of each of the terms in the sequence, it's possible that we're told to find the series of a sequence up until a certain term. So here we have S1, which means that we're looking for the series of the first term of our sequence only. Obviously, that's just 4. For S2, it means that we're told to find the series for the first 2 terms of our sequence. So that's going to be 4, which is the first term here, plus 2, which is the second term here. This is equal to 6. And S3 means the series of the first 3 terms. So that's 4 plus 2 plus 0, which is also equal to 6. S4 is 4 plus 2 plus 0 minus 2. And this is equal to 4. And S5, which is actually the series of the entire sequence, is 4 plus 2 plus 0 minus 2 minus 4. And this is equal to 0. So this example is just to show you that while we know that the series is the addition of all the terms in the sequence, it's possible that the question tells you to find the series of a sequence up until a certain term. So you should always look out for that. Now let's move ahead to the first kind of progression that we're going to be looking at, and that is arithmetic progression.